Hi class, this video will cover inverse functions, and what I'd like to note first is that when you are solving for an inverse function, f inverse, this is not an exponent, by the way, that is notation for an inverse function, so that is not like f raised to the negative first power. When you're solving for an inverse function, you solve for the original independent variable. So as a warm-up, I'm gonna cover 4 problems where we're gonna solve for the independent variable, and in each instance here, the independent variable is x. So I need to solve for x. Y is equal to the square root of x minus 2. If I want to solve for x, I'll add 2 to both sides. Y plus 2 is equal to the square root of x, and now I will raise both sides to the second power. And so x is equal to the quantity y plus 2 quantity squared. I've solved for the independent variable. Now, just to give you some extra information on notation, this may have said f of x is equal to y is equal to the square root of x minus 2. That's another way that I could have written that. I have just solved for x, and we say that x is equal to f inverse of y. And so instead of f of y, we say f inverse of y. Again, that is not an exponent. So this is proper notation. We found the inverse function. Second example, I'm down here. Y is equal to the square root of the quantity x minus 2. In this case, we'll square both sides first. And so we get y squared is equal to x minus 2. I'll add 2 to both sides, and x is equal to y squared plus 2. Again, that is my inverse function. So x is equal to f inverse of y would be the proper notation. Notice, first thing that I'd like you to notice is that the independent variable is now y. The independent variable in the inverse function is y, and the dependent variable in the inverse function is x. In other words, when you solve for an inverse function, the independent and dependent variables in the original function, they switch roles, and this means that the domain and range will also switch. Next example. Y is equal to 4x, so I might say f of x equals y is equal to 4x over the quantity 1 minus x. Again, we're asked to solve for x. I'll start by multiplying both sides by this quantity. I don't have much room, so let me just write this below. Y times the quantity 1 minus x is equal to 4x. I'll distribute my y. Y minus xy is equal to 4x. I'll add xy, so 4x plus xy is equal to y. I'll factor out an x. X times the quantity 4 plus y is equal to y. And I'll divide by 4 plus y. Divide both sides by 4 plus y. That reduces to 1. I've isolated x. Let me write this off to the side. And so we say that x is equal to y over 4 plus y. X again being f inverse of y. My independent variable now, the one that shows up in the equation, is y, and my dependent variable is x. Notice that the algebra skills that we have been working so hard on, those algebra skills are coming into play in every single one of these problems. So now you can see, I hope, why we had to work so hard on those algebra skills up front. Another reason we need them to solve for an inverse function. Okay, last but not least, y is equal to, and notice there's an exponent there, I don't want it to blend in. Y is equal to 5 minus open parenthesis 2x close parenthesis cubed. Well, we want to solve for x, which is the same as f inverse of y. Y is equal to 5 minus 8x cubed. Because exponent rules, I have to cube both my x and my 2. I have a product being cubed, and so both the 2 and the x get cubed. And again, we're solving for x, so I'll subtract 5. Y minus 5 is equal to negative 8x cubed. I'll divide both sides by negative 8. divide both sides by -8, and I'll take the cubed root. Let me change colors here. I'll take the cubed root of both sides. Notice the entire numerator and denominator, I'm taking the cubed root. Now, you have an 8 in your denominator here. I'm sorry, a -8. So another way that we could write that would be x equals the cubed root of, let's see, 5 minus y over positive 8. And of course, x is f inverse of y. Now, one more rule. If I'm taking the cubed root of a fraction, I could rewrite that as the cubed root of the numerator, 5 minus y, over the cubed root of 8, and the cubed root of 8 is 2. So this is an alternate way to express f inverse of y, which is x. Again, not an exponent. One more time, that is the inverse notation. All right, an important rule for inverse functions. If two functions are in fact inverses of each other, if two functions are inverses of one another, then if you evaluate f of f inverse of y, you will get y. It will clean up to be just y. And if you evaluate f inverse of f of x, you will just get x. Notice the independent variable when I'm taking my inverse function is y, and the dependent variable when I'm taking my inverse function is x. Let's look at an example. So if I have y is equal to f of x, which is 2x plus 8, find x is equal to f inverse of y, and show that the rule holds true. So I want to solve for x initially. Well, y is equal to 2x plus 8. I'll subtract 8. Y minus 8 is equal to 2x. I'll divide both sides by 2. Divide both sides by 2. And x is equal to y minus 8 over 2. That's my inverse function. Again, we can say x is equal to f inverse of y. Now, show that the rule holds true. In other words, show that, for example, f of f inverse of y reduces to y. Well, let's talk about that. If we evaluate f of f inverse of y, then I'm really evaluating f of y minus 8 over 2. And if I'm evaluating f of y minus 8 over 2, then I'm putting y minus 8 over 2 in as my input for f. So that goes in here. And so f of y minus 8 over 2 equates to 2 times the quantity y minus 8 over 2 plus 8. Well, if you think about that, 2 getting distributed to here is 2 times the quantity y minus 8 divided by 2 plus 8. That 2 over 2 reduces to 1. I'm left with y minus 8 plus 8, which is y. And so we've just shown that f of f inverse of y does in fact equal y. Now, you should, I'm going to ask you to try this one on your own, but you really should also check to show that f inverse of f of x equates to x. And if you do, I'll show you the first step. If you do, then I would say, okay, f inverse of 2x plus 8, because 2x plus 8 is f of x. Okay, this goes in, put this as your input. That goes into your inverse function. It goes in for your independent variable y. And when you put that in and clean this up, you should in fact get x. And so that shows that f inverse of f of x equates to x. These are inverse functions. Notice that what we've done here and here, okay, is we have used composite functions, composition of functions, which we've already talked about in class, to prove that f of f inverse of y equals y and f inverse of f of x equals x. Okay, next example. Find each inverse function. So we actually did this on the first slide. We just didn't really call it finding an inverse function. You're solving for the original independent variable. That's what we're doing here. And the variables could be anything. So for the sake of time, to keep this video reasonably short, I'm going to work through this one, and I'll work through this one, and I'll ask that you try these other two on your own. But let's start down here. So y is equal to f of s, which equals 2 plus 1 over s. Find the inverse function. Well, I know that if I want to find the inverse function, in the end I should have f inverse of my original independent variable, which is my original dependent variable, which is y. F inverse of y is equal to s is equal to some function. And so it's that function that we need to solve for, and we'll solve for it by solving for s. So I like to kind of ignore that piece. That's the function notation. We'll come back to that in a moment. And if I want to solve for s, isolate s, then I would subtract 2 first. So y minus 2 is equal to 1 over s. You have a couple of options. The most efficient would be just to take the reciprocal, okay, of each side, and we've solved for s. So s, if 1 over s is equal to y minus 2 over 1, then s over 1, or just s, is equal to 1 over y minus 2. So s is equal to 1 over y minus 2. S is equal to f inverse of y, which is 1 over y minus 2. There's your inverse function. Okay? Again, notice the algebra skills coming into play. Those are not going to go away. We'll use them all semester. Let's work through this other example. P is equal to f of x is equal to 4x over 1 minus 2x, and in the end, I need x is equal to f inverse of p is equal to some function. In other words, I need to solve for x. I need to get x by itself. You can ignore this for a moment. That's the function notation. I will start by multiplying both sides by the quantity 1 minus 2x. Multiply both sides by the quantity 1 minus 2x. That reduces to 1. I now distribute my p, and so p minus 2px equals 4x. Of course, we want to solve for x, so I'll move anything with an x to one side, everything else to the other. So p is equal to 4x plus 2px. I'll factor out my x. X times the quantity 4 plus 2p is equal to p, and you know the last step. You'll divide by that quantity, and you have now, that reduces to 1. You've now isolated x, which is what we wanted to do all along. X is equal to p over 4 plus 2p. There's your inverse function. I'll do one more. I think I have time. So let's look at this last one. M is equal to f of n is equal to 4 minus x cubed. Again, I need to solve, and I should have said these independent variables should match. So this should actually be an n cubed. Sorry about that. My independent variable here needs to match my independent variable here. So let's make that an n. And I need to solve for n. If I want the inverse function, then I want n, which is going to be equal to f inverse of m, which is going to be equal to something. I need to solve for n to get that. Okay, so again, we can ignore this initially. I'll add n cubed. I'll subtract 4. And so m minus 4 is equal to the opposite of n cubed. Well, we can divide by negative 1. That reduces just to positive n cubed. And if I divide by negative 1, that becomes a negative m plus 4, which is the same as 4 minus m. So 4 minus m is equal to n cubed. The inverse operation, I'll take the cubed root of both sides, and so n is equal to the cubed root of 4 minus m. Okay. For an inverse function, I talked about this earlier in the video. The roles of the independent and the dependent variables switch. This means that the domain and range also switch. In other words, the domain of the original function becomes the range of the inverse function, and vice versa. It's important that we talk about an interpretation problem. How might the inverse function be interpreted, or how might it relate? How might it relate to the original function. So I'll give you an example that really happened to me. I was painting my house when my wife and I bought a house. We moved in, and the first thing we needed to do was paint the exterior. So, you know, common sense says that I'm going to walk around my house and calculate how much the square footage is, and then use that to determine how many gallons of paint I need to buy. In that case, N, the number of gallons, is a function of A, area. In other words, the area that I need to paint is my independent variable, and the number of gallons that I'll buy depends on, that's my dependent, it depends on the area that I need to paint. So let's look at this first example. Interpret F of 4,000 is equal to 10. Take a moment, pause the video, think about that. Here's what it means. If I need to paint 4,000 square feet, remember this is A, as defined up here. If I need to paint 4,000 square feet, then I need to buy 10 gallons. Independent, f of x independent, number of square feet, dependent, number of gallons depends on number of square feet. But that's not always the case. I'll give you another example. Same house, we moved in, and the very first day that we moved in, I walked down to the basement and I found about a half a gallon of pink paint. Now, my 3-year-old daughter at the time was very excited. She has a closet, and she wanted to know if I could paint her closet pink. True story. So now let's look at the inverse function. For the inverse function, and talk about how that relates. For the inverse function, f inverse of n, this is an n value, is equal to a, this is an a value. Notice this was a and this was n in the original function. The roles have switched. And so what happened now is I actually know that I have 0.5 gallons of paint. I walked down to the basement. The previous owners had left us a half a gallon of paint. And the question is, well, what's the area that can now paint? Now the number of gallons is actually the independent variable. And the area that I can paint is dependent. And in that case, we were able to paint her closet pink. She was very excited. The roles got reversed. Independent in the inverse function was number of gallons. Dependent was area. Last slide. Give you a graphical version of inverse here. So I mentioned that independent and dependent values flip-flop. Okay? And so if you have... if I asked you to evaluate the verb we've been using, f of 0, okay, this is f of x, y is equal to f of x versus x is equal to f inverse of y, okay? So in this first example, we've got f of x, which tells us that this value right here is an x value. Okay, we are solving then for a y value. So we say when x is 0, what's y? Well, when x is 0, y is 13.8. Okay. Now, what about f of x equals 0? Well, again, this is f. This is not f inverse. So I'm working with this function. And you're now being asked to solve. What is x when y is 0? And we've talked about this in class many times. Okay. Again, in this case, when y is 0, x is 9.7. So the solution to this statement is x is equal to 9.7. All right. Notice how the roles get reversed for inverse. I now have f inverse of 0. And what I want you to notice is that when we have an inverse function, okay, this value is an output is a y value on the original graph. And so f inverse of 0 means that my y value is 0, and I need to find my x value when my y value is 0. Okay? So again, that actually represents this ordered pair. When your y value is 0, okay, when your y value is 0, what's your x value? Your x value is 9.7. This is not a fraction bar. That's just an open space to put the answer, 9.7. Versus, here's my inverse function. And I just noticed that this should actually have said y. Okay. So f inverse of y is equal to 0. In other words, when my x value is 0, what's my y value? Well, that would be 13.8. And so when x is 0, remember inverse function, your output is x, your input is y in this case. When x is 0, y is 13.8. Okay, that's all I've got.